Megger testing of Romex cables requires adherence to safety precautions. Firstly, ensure the circuit is de-energized before testing. Secondly, wear appropriate personal protective equipment. Thirdly, use the correct test voltage rated for the cable being tested. For 120 volt circuits, use a 500 volts Megger. For 240 volt circuits, use a 1000 volts Megger. Acceptable readings are greater than 100 megohms. Unacceptable readings are less than 100 megohms, indicating potential insulation damage. The test procedure is as follows. 1. Connect the Megger leads to the appropriate terminals on the cable. 2. Apply the test voltage for 60 seconds. 3. Record the insulation resistance value. 4. Repeat the test on each conductor. Megger test in the field can be affected by various factors, including moisture, temperature, contamination, and age of the cable. Therefore, field test results should be interpreted with caution. A low reading may not necessarily indicate insulation damage, but it warrants further investigation. For readings greater than 100 megohms, the cable has sufficient insulation resistance and is likely safe to use. For readings less than 100 megohms, further investigation is required. This may involve visual inspection for damage, additional Megger tests at different locations, and resistance testing. For readings below 10 megohms, the cable is likely damaged and should be replaced. If you are not comfortable performing Megger testing on Romex, it is advisable to hire a qualified electrician. Record the test results and provide them to the electrical inspector for review. If any unacceptable readings are obtained, consult an electrician for further guidance. When performing Megger tests, it's important to understand the underlying principles. A Megger, or insulation resistance tester, applies a high DC voltage to the conductors of a cable and measures the current that leaks through the insulation. The higher the resistance, the less current leaks, indicating better insulation integrity. The test voltage is chosen to stress the insulation without damaging it, and the applied voltage level depends on the cable's voltage rating. The duration of the test, typically 60 seconds, allows the capacitance of the cable to charge fully, providing a stable resistance reading. Factors affecting field test reliability are crucial to consider because they can significantly influence the test results. Moisture, for example, can lower insulation resistance by providing a conductive path. Temperature also affects insulation resistance. Higher temperatures generally decrease resistance. Contamination, such as dust or chemicals, can create leakage paths. The age of the cable is another factor, as insulation degrades over time, reducing its resistance. When interpreting test results, it's essential to consider these factors and compare readings to previous tests or manufacturer specifications, if available. A trend of decreasing insulation resistance over time is often more informative than a single reading. Visual inspection is a critical part of the investigation when unacceptable readings are obtained. Look for signs of physical damage to the cable, such as cuts, abrasions, or discoloration. Check the connections at junction boxes and devices for tightness and corrosion. Any visible damage should be addressed before further testing is performed. Additional Megger tests at different locations along the cable can help pinpoint the location of the insulation fault. By testing sections of the cable, you can isolate the area with the lowest resistance. Resistance testing, using a standard ohmmeter, can be used to check for continuity and shorts between conductors. This test is performed with the power off and the cable disconnected from the circuit. Understanding the specifications of Romex cable is also important. Romex, also known as non-metallic sheath cable, typically consists of 2 or more insulated conductors enclosed in a non-metallic sheath. The insulation is usually made of polyvinyl chloride, or PVC, which has specific dielectric properties. The National Electrical Code, or NEC, provides guidelines for the installation and use of Romex cable, including requirements for ampacity, overcurrent protection, and grounding. When troubleshooting low insulation resistance, consider the possibility of water intrusion. Water can enter the cable through damaged insulation or leaky connections. If water is suspected, try to dry the cable and retest it. If the insulation resistance improves significantly after drying, this confirms that water was the problem. In some cases, low insulation resistance may be caused by a faulty device connected to the circuit, such as a light fixture or appliance. Disconnecting devices one by one and retesting the circuit after each disconnection can help identify the faulty device. Remember that Megger testing is a valuable tool for assessing the condition of electrical insulation, but it is not a substitute for proper electrical safety practices. Always de-energize circuits before testing, wear appropriate personal protective equipment, and follow the manufacturer's instructions for the Megger. Document all test results, including the date, time, location, and readings. This information can be useful for tracking changes in insulation resistance over time and identifying potential problems before they become serious. The acceptable insulation resistance value of greater than 100 megohms is a general guideline. The actual acceptable value may vary depending on the specific cable, the environment, and the application. Always refer to the manufacturer's specifications or consult with a qualified electrician for guidance. Consider these points when performing insulation resistance testing. Firstly, ensure the Megger is properly calibrated. Secondly, use the correct test voltage. Thirdly, test each conductor to ground and conductor to conductor. Fourthly, record the ambient temperature and humidity. Fifthly, compare the results to previous tests or manufacturer specifications. Sixthly, investigate any low readings. Seventhly, document all test results. Eighthly, follow all safety precautions. When interpreting Megger test results, it's crucial to understand the limitations of the test. A Megger test only measures the insulation resistance at the time of the test. It does not provide information about the long-term durability of the insulation or its ability to withstand voltage surges or other stresses. Therefore, Megger testing should be used in conjunction with other tests and inspections to provide a comprehensive assessment of the electrical system. In addition to the factors already mentioned, other factors can affect the reliability of Megger tests. These include the presence of surface contamination on the insulation, the type of insulation material, and the frequency of the test voltage. Surface contamination can create leakage paths that lower the insulation resistance. Different insulation materials have different dielectric properties, which can affect the Megger reading. The frequency of the test voltage can also affect the Megger reading, especially for cables with high capacitance. A Megger applies a direct current, or DC voltage, to the cable. The insulation resistance is calculated by dividing the applied voltage by the measured current. A high resistance indicates good insulation, while a low resistance indicates poor insulation. The test voltage should be selected based on the voltage rating of the cable. The voltage should be high enough to stress the insulation, but not so high that it damages it. The test duration should be long enough to allow the capacitance of the cable to charge fully, typically 60 seconds. When testing long cables, it may be necessary to increase the test duration to ensure accurate results. It is also important to ensure that the Megger is properly grounded during the test. This will prevent the test voltage from damaging sensitive electronic equipment. If the insulation resistance is low, it may be necessary to perform additional tests to determine the cause of the problem. These tests may include visual inspection, continuity testing, and voltage drop testing. Visual inspection can identify physical damage to the insulation, such as cracks, cuts, or abrasions. Continuity testing can identify shorts between conductors. Voltage drop testing can identify loose connections or undersized conductors. These tests can help determine the cause of the low insulation resistance and identify the appropriate corrective action. Remember that Megger testing is a valuable tool for maintaining the safety and reliability of electrical systems. By following the proper procedures and interpreting the results carefully, you can identify potential problems before they become serious hazards. Always prioritize safety when working with electricity and consult with a qualified electrician if you have any questions or concerns. Consider also that newer electronic devices may be damaged by Megger testing if they are not disconnected. Therefore, it is crucial to isolate all sensitive equipment before performing a Megger test. Surge protection devices, such as surge suppressors, should also be disconnected before testing, as they can provide a low-resistance path to ground. Also, when testing circuits with multiple branch circuits, it may be necessary to isolate the branch circuits to pinpoint the location of the lower insulation resistance. This can be done by disconnecting the branch circuit conductors at the panel board and testing each branch circuit separately. And finally, always refer to the National Electrical Code and other applicable standards for specific requirements related to Megger testing. The NEC provides guidance and the proper procedures for electrical testing and maintenance, and it is essential to follow these guidelines to ensure safety and compliance. A final thought: the goal of Megger testing is to verify the integrity of the insulation and prevent electrical failures. By understanding the principles of Megger testing and following the proper procedures, you can contribute to a safer and more reliable electrical system.